Okay, so we're asked to graph a function f that obeys all of these interesting properties on its derivative and its double derivative. So remember that the derivative being equal to 0 is when f experiences a horizontal tangent line, a sort of point of flatness. That occurs wherever f has a max, or wherever it has a min, or it can also do like the function x cubed and kind of have a point of flatness but be increasing on either side, or vice versa. It could decrease on both sides and have a point of flatness, like the function negative x cubed, for example. Alright, so these are kind of the four kind of drawings that we're going to be aware of, but we don't know which one each of these points is. We know that f at 0, 2, and 4 is going to experience one of these four drawings in each place, but that still leaves lots of possibilities open. But what we can do is we can go to the x-axis and we can mark off those points. We know something interesting is going to happen at those points. There's going to be a point of flatness. So let me go down to the graph on the x-axis and mark off the points where x are 0, 2, and 4 respectively. So here's where it's 0, here's where it's 2, and here's where it's 4. Okay. Now we also know that the derivative is positive for negative values of x when x is less than 0, and whenever x is between 2 and 4. So I'm going to kind of mark off, we've already marked off 0, 2, and 4 as interesting points where there's a shift. So I'll leave those like that for a moment. And I know that f prime is less than 0 when x is between 0 and 2 and when x is bigger than 4. Again, 0, 2, and 4 seem to be the places where shifts happen. So I've already marked those off. But we also have a shift in the sign of the double derivative. And remember that the double derivative being positive means that f is concave up. And the double derivative being negative is when f is concave down. So there's a shift in concavity. And let me mark those out on the x-axis too, and maybe I'll use green for that. So there's a shift at 1 and a shift at 3. So here and here. So the green points denote a shift in concavity, and the red points on the x-axis denote where there's a shift in the sign of f prime. And remember that now that we've mentioned it, switch back to red here. F prime being positive means that f is increasing, and f prime being negative means that f is decreasing. So now we've gotten all these points drawn out. That means that we've chopped up the entire x-axis into 1, 2, 3, 4, 5, 6 separate intervals. Okay? And what we want to pay attention to is the sign that f is taking, or the sign that, its derivative and its double derivative are taking on each of these sub-intervals. For example, if f prime is positive and f double prime is positive on one of these sub-intervals, that means that we're concave up and increasing on that interval, which means we should draw the graph something like that. So that's what we really want to figure out. So let's color code this thing. Let's make it real easy, and I'll even use more exotic colors in a moment. But let's draw the interval in blue if f prime is positive and f double prime is positive on that subinterval. Okay, let's draw the interval in, well, gray's already there, but I can leave it as gray. Let's draw it in gray if f prime is positive, which means we're increasing, but f double prime is negative, which means we're concave down. So that would look something like that. Concave down, but still increasing. What else is possible? Maybe we're not increasing, maybe we're decreasing. So I don't want to use red or green, so I'll use black. Black will denote the situation where f prime is negative, but f double prime is positive. So we're concave up, but we're decreasing. So the picture would look something like that. That's what black will represent. And then I'll come up with a more exotic color here. Let's say we pick orange to denote the situation where f prime is negative, so we're decreasing, and f double prime is negative, so we're concave down. So the graph would look something like that. Alright, so each of these 6 subintervals that I've drawn here are going to get color-coded either blue, gray, black, or orange. So let's figure out what they should be. To the left of this first red dot, this x equals 0 dot, that is for negative values of x, what are the signs of f prime and f double prime? Well, here, this first rule tells me that for x negative, my derivative is positive. So I'm increasing. I'm in one of these two situations. Alright? But what is my f double prime doing? Well, when x is less than 1, so in particular when x is negative, it's less than 0, I know f double prime is negative. So I'm actually in this situation here. So I should be drawing things in gray. So I could take my gray pen and just kind of, and I guess I'll do it. I mean, the axes are already in gray, but I'll just highlight it even more in gray. So here, I'm going to be drawing the picture increasing but concave down. I'm going to be drawing a picture that looks like that. But before I do, let's continue and figure out the rest of these little subintervals. So here, between 0 and 1, between this red and green point, what's happening? Well, I know that for x between 0 and 2, so certainly between 0 and 1, f prime is negative, which means I'm decreasing. So I'm in one of these latter two situations. And as for f double prime, well, I know that between 0 and 1, I'm still less than 1, so my f double prime is still negative. Okay, so that means that I'm in this last situation, so I should draw the interval in orange here. Because both my, so that doesn't look like orange. Did I click the wrong thing? Orange, there we go. That's an orange interval right there. So hopefully you can go through and do the rest of these yourself. I'll do it very rapidly. Let's just figure out what these things are. Between 1 and 2, looks like my f prime is negative, so I'm decreasing. And my f double prime between 1 and 2, f double prime is positive, so I'm in black interval. So let me swap over to black. And that's my next subinterval. Okay, now between 2 and 3, looks like I'm in this situation for f prime, and I'm in this situation for f double prime. So f double prime is positive, so is f prime. So that would put me in a blue interval over here. So that's a blue interval. Now between 3 and 4, it looks like f prime is still here. F prime still positive, but now for x bigger than 3, f double prime is negative. So that puts me in the gray situation. So switch over to gray and highlight that. And then finally, when I'm bigger than 4, my f double prime is negative, and so is my f prime. So that puts me back in the orange situation. The rest of the way. There we go. Just like that. And remember that at each of these 3 red dots, I should draw the graph of f as if it kind of has a sort of flatness. So that's something we're going to be paying attention to. Alright, but first, let me even draw this still in a color-coded way. On my gray areas, my graph should look like this. So I should be increasing and concave down, and then at 0, I should have a point of flatness there. Now I'm going to switch over to orange. And for this little orange subinterval, f prime's negative, so I'm decreasing. I'm also concave down, so it should draw like that. So it should look something like that. Okay. Then I hit a green point, which is not a point of flatness, but it's a shift in concavity. So if I was concave down before, I'm going to switch to concave up. And that's all black is. We're still decreasing. I'm in this black subinterval now. We're still decreasing, but now we're concave up. So I'll draw it in black now. we're concave up. Then I hit another red point, which means another point of flatness. Then I hit a blue interval, and the blue, we're increasing and concave up. So let me switch over to blue. Increasing, concave up. So it should look something like this. Now, we hit another green point, which means there's a shift in concavity, but it's not a point of flatness. Those are just the red points on the x-axis. So I'm now in the gray interval, and like we said, it looks like this. Concave down, but still increasing. I will switch colors, so everything stays nice and color-coded. So it should look like this. Now I should start drawing things concave down, and there is a point of flatness here at x equals 4, so I'll draw that point of flatness. And then I'm in the orange area again, which means I'm concave down and decreasing. So it would look like this, and that's what happens for the rest of the values of x. So that's more or less what the graph should hopefully look like.